So this is the 12th video on friction. In this video also I'll take up a numerical problem on kinetic friction. Okay, I'll take up a numerical problem on kinetic friction. So I first write down the question. Okay, question is this: a board is fixed. Board is fixed to the floor of an elevator. To the floor of an elevator, such that the board forms an angle of theta equal to 37 degree with the horizontal floor. Horizontal floor of an elevator accelerating upward, moving upward, constant acceleration A with respect to ground. Okay, a block is placed on point A of the board as shown at the A of the board as shown. Okay, board A as shown. When it is given and initial speed v1 equal to 4 root 2 meter per second with respect to wedge, with respect to elevator or wedge, whatever you might call it, elevator, it comes to rest with respect to elevator after moving a distance L, after moving a distance L equal to 1.6 meter relative to the board. After that, the block moves down the incline. And when it reaches A, its speed with respect to wedge or elevator, whatever you might call, they are fixed with respect to each other, is v2 equal to 4 meter per second. Okay, find two things. Find first A is what? Acceleration of elevator with respect to ground, and friction coefficient mu between the block and the inclined plane of the board. Okay, G has to be taken to be 10 meter per second square, and sine 37 degree is given to be 0.6. Famous angle of physics, 37 degree. Sin 37 degree is given to be 0.6. So cos 37 degree becomes 0.8. and tan 37 degree becomes 3 by 4. All right. So this is the question. Okay, fine. I'll rub this one. Okay. First, what I'll do, I'll draw the diagram of the situation and then I'll solve the problem. Okay. I'll draw the diagram of the situation. So this is the elevator, side view of elevator, moving upward with a constant acceleration a with respect to ground. This is the board which is fixed to the floor of elevator. It makes an angle of theta equal to 37 degree with the horizontal floor. This is the lowest point A. A block is projected from this point A with initial speed v1 equal to 4 root 2 meter per second with respect to elevator. If the block comes to rest here after covering a distance L1 with respect to elevator, L is just given to be 1.6 meter, and then it begins to slide down the incline, and when it reaches this original location A, its speed with respect to incline is v2 equal to 4 meter per second down the incline. Its speed v2 is equal to 4 meter per second down the incline. Now we have to determine mu and A. Mu is the friction coefficient between the block and the inclined plane. Mu is the coefficient of friction between the block and the inclined plane. Alright, fine. So now see, first of all, I will solve the problem in the frame of elevator. That is much more convenient. First thing I have told. Elevator or board, whatever you call, they are fixed with respect to each other. So I will solve the problem in the frame of elevator. That is the first point. The question solved with respect to elevator frame. First point. Now see, there are two phases of motion of the block. First is while it is moving up the board with respect to elevator, that is the upward journey of the block with respect to elevator, and then it begins to move down the board with respect to elevator, that's the downward journey. So there are two phases of motion of block with respect to elevator. First it is moving up the inclined plane with respect to elevator, and then it is moving down the inclined plane with respect to elevator. Alright. So what I'll do, I will analyze both the motions separately. Okay. So now let us consider the upward journey of block with respect to elevator, upward journey. So case 1. Upward journey let's not phase 1, let's call it phase 1, sorry, not case 1, phase 1. Okay, first phase. Upward journey of block with respect to elevator. Okay. So while block is moving up the incline, suppose at some instant it has come here. Diagram I am showing smaller to get more space. This elevator is moving up. At some instant the block is here and moving up the incline with respect to elevator. I draw its free body at this point with respect to elevator frame. So first the real force mg acts on it. This inclined face exerts a normal force N1 on the block. Now the block is slipping over the inclined face of the wedge. So the friction will act on it, friction F1 will act on it down the incline. Now elevator is accelerating with respect to ground. So elevator is a translating non-inertial reference frame. So as seen from elevator frame, a pseudo force Ma will act on the block down the incline. Okay. And here slipping is taking place. So F1 will just be equal to mu N1, where mu is the friction coefficient between the block and the inclined plane. Mu is the coefficient of friction between the block and the inclined plane. So now while it is moving up, it's slowing down with respect to elevator. That means during its upward journey, it is accelerating in downward direction with respect to elevator. So suppose its downward acceleration is equal to A1 in magnitude. So first what I do, I apply Newton's second law to block with respect to elevator down the incline during its upward journey. Okay. So net force on the block down the incline becomes mg plus ma cos theta sin theta. Component of these two forces down the incline will be mg sin theta plus ma sin theta. So what do I write? mg sin theta plus ma sin theta plus f1. n1 has no component down the incline. That is equals to m times a1. Now see, I'll wrap this one now. Now your slipping is taking place. The block is slipping over the rough surface of the wedge. So F1 will be equal to mu times N1 as I written it here itself. Now to know E1 we must know F1. To know F1 we must know N1. Now how to find N1? I apply Newton's second law to block with respect to wedge in this direction, along direction of N1. So what will I write there? N1 minus mg cos theta plus ma cos theta. Is equals to mass times acceleration of block with respect to wedge in this direction, which is simply a1 cos 90 degree. a1 cos 90 degree, which is simply 0. That becomes 0. So n1 becomes m into g plus a, simplifying it, m becomes common, cos theta. So this becomes n1. So this n1 is substitute here, we get f1. This f1 I put here, we get the value of a1. So from this, if substituting this n1 in this equation, what do we get? M a1 becomes m g plus a into sin theta plus mu times n1. n1 is this much, g plus a into cos theta. Now m goes away. So a1 becomes g plus a into sin theta plus mu cos theta. This is the value of a1. Now this is seen to be a constant quantity because all the quantities in the problem are constant. Now what I do, this is directed down the incline. This is directed where? Down the incline. Alright, it is seen to be a constant. During the phase 1, the block is moving in a straight line with respect to elevator with a constant acceleration a1 down the incline and initial speed v1. And after covering a distance L, its speed becomes 0 with respect to elevator instantaneously. So apply that formula v square equal to u square plus 2at to the block with respect to elevator. Taking, okay, fine. What do I write? U square, this formula apply. I apply this formula. So v is the speed of block with respect to elevator when it has covered a distance L. That is 0 because after covering a distance L, its speed with respect to elevator becomes 0. So v square becomes 0 square. Now what is u? U is simply v1 4 root 2. Sorry. U is simply v1, so v1 square. And all this u, v, ad have to be taken with proper sign. Up the incline I take to be positive. Down the incline becomes negative. So a will be written as minus a1 and d is simply L. L is 1.6 meter as it is given in the problem. Fine. So I rub this one now. So now I simplify this equation. 2a1L. Alright. Now v1 is how much? 4 root 2. I'll remain v1 itself. So v1 becomes 2. a1 is this quantity. Substitute this a1 there. Sin theta plus mu cos theta. Sin theta plus mu cos theta into L. Okay. So this is the first one equation which I have obtained now. Let's call this equation 1. Okay, fine. Now what I do, I take phase 2, in which I consider the downward journey of block with respect to elevator, downward journey. Phase 2. Phase 2 is the downward journey on the block with respect to elevator. It is the downward journey of the block with respect to elevator, okay. Now, again in phase 2, first what I do, this angle theta, elevator is moving up. The block is moving down with respect to elevator or with respect to board, whatever you might call it. The block is somewhere here. It is moving down with respect to elevator. Now again I draw its free body with respect to elevator. So real force will act on it. One real force is simply mg. One normal force is simply n2. Okay. And the block is slipping of the rough surface down the incline. So inclined plane will exert a friction F2 on the block up the incline opposite to direction of relative slip. Also elevator is a translating NIRF. So single pseudo force MA will act on the block in downward direction. Alright. MA. Fine. Alright. Now see, during its downward journey, initially when it started its downward journey, at that instant it was initially at rest with respect to elevator, and then it is moving down. That is, its speed with respect to elevator is increasing in downward journey. So that means in downward journey it is accelerating in downward direction with some constant acceleration A2 with respect to the elevator. Okay. Now to find A2, I apply Newton's second law to block down the incline with respect to elevator. So what is the net force on the block down the incline with respect to elevator? This plus this into sine theta. mg plus ma into sine theta minus f2 is equal to ma2. Alright. Now we must know f2. Here slipping is taking place over the rough surface. So f2 will be written as mu times n2. Now to know f2 we must know n2. Now question is how to find the value of n2. I love this equation. Okay. This equation I already written here, so this I can rub it. Okay. So now to know f2 we must know n2. To know n2, what I do, apply Newton's second law to block with respect to elevator in this direction. In this direction, n2 minus mg plus ma cos theta. mg plus ma into cos theta. f2 has no component in this direction because it is right angles to n2. That is equals to mass times acceleration of block with respect to elevator in this direction, which is simply a2 cos 90 degree. Cos 90 degree is known to be 0, so right side becomes 0. So n2 becomes this side, shift that side, I take n to be common. mg plus a into cos theta, this is n2. This n2 is substitute here, we get f2 mu m into g plus a into cos theta. This f2 is substitute in this formula. M is common in that. mg plus a sin theta minus mu m into g plus a into cos theta is equal to ma2. M goes away. a2 becomes g plus a common sin theta minus mu cos theta. I hope it is clear. Now again it is seen to be a constant quantity. So that meaning in downward journey the block is moving in a straight line with respect to elevator with a constant downward acceleration a2 with respect to elevator, and when it reaches its original location its speed is v2. So apply that formula v square equal to u square plus 2ad to the block down the inclined plane with respect to the elevator. So initial final speed v2 square 0 square. In downward journey I take down the incline to be positive. So plus a2 into L. So v2 square becomes 2a2L. a2 is this much. G plus a into sin theta minus mu cos theta into L. Alright. This is therefore the second equation. From these two equations we have to determine the value of mu and a. Alright. Now rub this everything here. Okay. So this is the second equation. I write it here. G plus a into sin theta minus mu cos theta into L. And this equation also I know. V1 is how much? 4 root 2. I suppose you understand what is V1. V1 is given to be how much? 4 root 2. So substitute 4 root 2 here. And V2 is 4. So I substitute V2 4 here. 16 equal to 2 times G plus a into sin theta minus mu cos theta into L. And here V1 is 4 root 2. The V1 square becomes 32. 4 root 2 whole square is 32. That becomes 2 times G plus a sin theta plus mu cos theta into L. Now what I do, I divide this by this. 32 by 16 I divide. 2g plus I will cancel out. L will also cancel out. What I'll get is simply sine theta plus mu cos theta by sine theta minus mu cos theta. Okay. Now 32 by 16 is simply 2. Now sine theta is sine 37 degree, theta is 37 degree. Sine 37 degree is simply 0.6. Cos of 37 degree is 0.8 from trigonometry. Minus 0.8 mu is equal to 2. Alright, fine. Now I simplify, multiply it by point goes away. 6 plus 8 mu, 2 times 6 minus 8 mu. I hope it is clear. So 6 plus 8 mu, 12 minus 16 mu. So from this I see 16 plus 8 becomes 24. 24 mu is equal to 12 minus 6 is 6. So mu becomes 6 by 24. That is 1 by 4, which is therefore the one answer. The value of mu turns out to be 1 by 4. This is the value of mu. The value of mu becomes 1 by 4. One answer I have given. Alright. Now I substitute the value of mu either of this or this, any one of them. I'll get the value of A also. Alright. Now rub it there. So substitute mu in this formula, suppose. So this is 16. 2 times G plus A. L is simply 1.6 meter. It is given to 1.6 meter. Sin theta minus mu cos theta. Sin 37 degree is simply 0.6. Mu is 1 by 4. Cos theta is simply 0.8 from trigonometry. So this becomes 2 into 6, 1.6. That becomes 3.2. 16 by 3.2 becomes 5. G plus A. This becomes 0.6 minus 0.8 by minus 0.2. It becomes, I suppose it is clear. 0.8 by 4 is simply 0.2. Okay. So 5 is equal to G plus A into 0.6 minus 0.2 is 0.4. So G plus A becomes 5 by 0.4. 5 by 0.4 becomes 12.5. I suppose it is clear. 2 by 5. 0.4 is 2 by 5. 5 goes up. So G plus A is 12.5. G is equal to 10. Plus A equal to 12.5. A becomes 2.5 meter per second square. This is therefore the required answer. Okay. The value of A turns out to be 2.5 meter per second square. Okay. This is the value of A. A is equal to 2.5 meter per second square. This is therefore the required answer to the second part of the question. So I hope you understand this problem. Okay. So go through it properly. In case you have some doubt, put it in the comment box. I'll clarify it. So in coming video also I'll take up more and more problems of kinetic friction. Okay. So this I close it here. Fine. All right.